let's consider one body, so which is made up of some dimensions, like consider like 100 by 100 into 100, the 3D body. Okay, on this
Okay.
body we are applying a load. For example, this
Okay.
load right now it is 1 kg. Right now the load is 1 kg, or we can consider as 10 kilo or 10 newtons, we can consider as 10 meters. If I increase this one, if I increase the load every time or every second, so at particular time the entire body is going to fail, right?
Yes, sir.
How it is going to fail?
When it loses the elasticity or stress points.
So when it loses its elasticity, or it is a point where the it reaches to maximum stress, right?
Yes, sir.
Then how we are going to define its maximum stress? How I going to define its maximum velocity?
I don't.
Okay. So generally we know that stress is equal to force by area, right?
Yes, sir.
So if I keeps on adding the force on an area, let's consider this area is given, right? 100 into 100. So 100
Okay.
into 100. If I keeps on adding, for example, right now it is 10 kilonewtons. 10 kilonewtons. So when I'm going to divide this 0 and 0, it becomes 1 by 1000,
By
or you can
thousand.
consider as 1 into 10 to
Zero.
power of minus 3
Six.
Pascal or megapascal, we can consider this, right?
Yes, sir.
So that means whenever I increase the load, okay, instead of 10, I'm going to specify that becomes it is becomes 2 into 10 to power of minus 3, right?
Yes, sir.
So whenever I increase the load, automatically the stress value is going to increase, right?
Yes, sir.
Can I simply write this one, sigma directly proportional to force?
Yes, sir.
If force increases and followed by stress also increases.
Okay.
Or can I write it as well? Sigma directly proportional to 1 by a. If area decreases, stress increases. So that means whether the body is as ideal body, whether the body is ideal body, that means body is not going to change, or there are some modifications are done in the body. Both affects
Okay.
stress. Okay,
Okay.
both
Yes,
affects
sir.
stress value. So that means whenever I change certain thing on the body, so automatically the load and the followed by load and followed by area changes. So when it is going to give a reaction that on the stress values.
Okay.
Simple. So if force or area change, stress also change.
Okay.
So similarly, can I write like this also? Strain is equal to change of length by vaginal length.
Yes, sir.
So here let's consider the height of the particular tube is a length, that means change of length by 100. So whenever I change I increase this load, okay, did it
Yes, sir.
affects the deformation, this change of length?
Yes, sir.
How? Because we are
Sir.
not there is no relation between these two values, right? There is no relation between these two values, right?
Yes, sir.
But can I write like this? Young's modulus is equal to stress by strain. Can I write this one?
Yes, sir.
That means stress is equal to F by A, strain is equal to change of length by total length. That is equal to Young's modulus. Can I write E, capital E?
Yes, sir.
So Young's modulus depends upon the type of the material what we selected. Okay.
Okay.
Before we only change force and followed by area. That is going to affect
Okay.
the stress.
Yes,
Right now,
yes.
I'm going to change the material itself. That means Young's modulus.
Okay.
So that means, can I write this one? Change of length is equal to FL by AE. Can I write like this?
Yes, sir.
That means, so change of length can be affected by change of force, Change of length can be affected by change of length. Change of length can be affected by inverse of area, and also by change of length is affected by change of material or Young's
Okay.
modulus. So that means whenever we manufacture a body or anything on the in real time industries, so
Okay.
something is, if I change something, it definitely affects the body's strength, because we know that strength is directly opposed by stress also. Again, strength directly proportional to stress again.
Yes.
Why? Because there is a safety factor involved in it. Safety factor is equal to, and we have to specify safety factor is equal to 1, where safety factor is equal to applied stress by actual stress is equal to 1. You should
Okay.
not get less than 1. So if you get the less than 1, the body is failed. If you get more than 1, the body is success, like that.
Okay.
So that means whatever you do in the research, whatever do in the analysis, every value gives a certain answer. We have to validate that answer according to the geometry. So there is no such thing that is a right answer. Remember that one. There is no such thing that it is a right answer. Only thing is that we have to follow the methods, and based on the methods only we can identify whether the body is having this much of deformation or stresses or strain. Okay,
Okay.
so even though if there is a change of length, it is also affects, change of force is also affects, everything is going to affect. So because of that one, there is no proper value for the results, there is no proper values in the results. We have to assume that how much we are getting and how much we are required to submit that one. Suppose how much we are comparing it.
Okay.
So generally everybody should not get, everybody, even the metal or whatever is there, so only not plastic, everybody should not get 5% of total length elongation.
Okay.
Suppose there is a 100 mm is there, for 100 mm should not get more than 5 mm.
Okay.
So body is 100 mm is there, if it should not get more than 5 mm. So if it is get more than 500, the body is elongated more than 105. So if it is going elongated more than 5, the molecule bonding between the atom to atom is going to break itself.
Okay.
So we will see that one later. But based on the requirement, we need to understand it should not cross 5%. So there are different types of materials are there which can go up to 10%.
Okay.
So that's why I'm going to call as limited elongation materials or stretchable elongation materials, like springs or otherwise tensile strengths, like the different types of materials are there which can go to up to 10%. There are another
Okay.
materials which can go to 100%, like rubbers.
Okay.
So that means there is no certain value again here also, but we need to follow the process. So for that one I'm going to open one website called as Make It Form. So in this website, we can find the material properties and its database. Click on this one. Let's consider one material here. So I want to choose aluminum material. So let's see what the result, what are the types of material it's going to have. So here we have aluminum. Click on that one. Then we can see different types of series are there. That means even though we selected one type of material, in the one type material there are alloys also there.
Okay.
So let's choose 1000 series. In the 1000 series, again different types of 1000 series are there. 1005, 1050, 1060, different types are there. You can choose any one of that one. Again, so we'll get in that one we can see hardness materials. So different types of materials are there. That's why there is no proper agenda. There is no proper specifications for the geometry. We have to choose only this material. So that's why the company required to research which material is suitable for the particular component. So we are not going to decide when it is manufactured. We are going to decide by using analysis method what material is going to be used for that component. So
Okay.
randomly we can't pick cast iron, randomly I can't pick stainless steel like that. So we have to make sure that we have to do a research, and followed by we have to find the strength and weaknesses of the particular geometry based on the material we selected. Then we have to compare it, then we can see which type of body and which type of material is suitable for it.
Okay.
So that means if you selected any component like piston is there, so directly we can't do a this aluminum material for it. So we have to do a research on that one. In the aluminum materials, which one is suitable for that one? Again, we have to do a research on that one. You have to apply the multiple types of loads. So 10 kilonewtons, 20 kilonewtons, 30 kilonewtons. We have to do multiple analysis on that one, so that we can find the what is the difference actually caused on the particular body.
Okay.
So there is no proper agenda is there. There is no proper answer is there. Only methods are there. We have to follow the methods. That's it.
Okay.
Now see in the aluminum 1050 H2112 material. So if I go downward direction, we can see Young's modulus and elongation breaks at 20% is given. So you can see that elongation break is 20%. That means the body can go up to 20% of its virginal length.
Okay.
Okay, so different types of material properties will be given on this website, so you can download, you can simply log in whenever you want to choose. It is a free, and we can choose the different materials also, and we can see the which type of material have which properties also there. So we can see Young's
Okay.
modulus, fatigue strength as the Poisson ratio, shear module, shear strength, tensile limit, etc., etc. We can see all the properties. We can see both electrical and mechanical, both will be there here. So we can simply copy the values and paste on the software, or we can simply select that one also, no problem.
Okay.
Okay, now let's do
Yes,
one
sir.
thing. Let's consider a beam. Let's consider a beam. The beam is fixed at one end. A beam is fixed at one end. I'm going to fix it here. Okay, and I'm going to
Yes, sir.
apply a load on here. Let's consider distance from here to here. It is uh, 1 meter, and the load is 10 kilonewtons, and followed by I'm going to apply one more load here. Distance from here to here is 2 meters, and here it is the load is 20 kilonewtons, and the end of the section I'm going to apply a load like this horizontally, which is
Okay.
having 60 kilonewtons, right?
Yes, sir.
The distance from here to here, the final distance here to here is 30 meters, 3 meters. So we have some section here, we have some diagram here which explain, which having some of the loads, right?
Yes, sir.
So that means this is this body. So this body, definitely if I see this thing, I can draw like this, right? So I can go to this one, is coming downward direction, that's why I can draw like this. It's coming more downward direction, so that's why I'm going to draw like this, and followed by up to here I'm writing. Because of this extension, this because of this tensile force here, it can be elongated more.
Okay.
So here I want to see the deformation of this particular beam, in x direction and followed by in y direction. So in x direction I want to see, in the y direction I want to see the deformations here.
Okay.
So for this one, let's select the cross section here. I'm going to consider the cross section as 0.5 meters into 0.5 meter as a cross section. I want to create this one in Ansys software. Okay.
Yes, sir.
Now let's open the Ansys software. Simply type Workbench on the screen. I'm not selecting anything, simply I'm going to create that body, and I want to apply the loads, so that how the software is going to work I want to see.
Okay, sir.
Now see,
Yes, sir.
so here this entire screen I'm going to capture here. So we can see left side some names, right? This six.
Yes, sir.
Okay, this is called analysis systems. Analysis system. So where contains a default templates. Default templates are steps of are steps of program of analysis
Okay.
methods. So simply we can call as analysis system, or we can call as templates, or we can call as steps of programming of analysis method. So that means every steps is already arranged here. We have to follow the steps, that's it only. Okay, so no need to create by zero onwards, everything will be there, so directly we can select it. In this one,
Okay.
okay, in this one we can see three colors. Remember, in this one we can see three colors. So first one is a green color, green. Second one is red, and third one is blue.
Yes, sir.
Okay, so red indicates structural type of models. Red indicates structural types of model analysis. So because suppose any body is there, only physical type of load, only physical types of load, that means force, pressure, momentum, couple, and displacement type of loads can be applied on this one. Force,
Okay.
pressure, momentum, couple, and displacement. Displacement means how much is going should compress, like that also. Only this type physically applied loads can be considered as when the body is subjected to physically applied loads. Those type of analysis can be considered as structural analysis,
Okay.
or we can simply say structural analysis is to applied when the body is subjected to a physical loads. Suppose the body is not subject to physical loads, the body is subject to natural loads, like temperature, atmosphere temperature, or we are burning it, source temperature. Atmosphere temperature, source temperature, temperature may be positive, temperature may be negative, doesn't matter. So based on this one here, if the load is there, if suppose any load is there, okay, if a load is
Okay.
applied here, so if it is perpendicular to our face, if it is perpendicular to face, then it will be considered as compression. It is opposite to the face, then it will be considered as tensile, right?
Yes, sir.
So can I write like this? It is a minus load and it is a positive load. It is adding the pushing it, it is compressing it.
Yes, sir.
So no, we can't write it. We can't write like that. So because the force, pressure, momentum always depends upon the direction,
Okay.
not negative, positive. There is no negative force, negative pressure. There is nothing like that. Only direction is there. Okay, inward force, outside force will be there. So make sure that when you are going to use a physical type of analysis, the value will be there and followed by direction will be there,
Okay.
where the temperature have negative temperature, positive temperature, like that. See, the physical doesn't have negative values, physical doesn't have negative values, only direction will be there. For thermal or non-physical, thermal, so these things have only both have negative and positive. It can be negative temperature or positive temperature. So that's why we have heat reduction is heat uh, call as reduction and followed by heat gain.
Okay.
We never seen that, we never heard force rejected, force added, force becomes zero. Okay, no problem on that one, force becomes zero. Okay, so somewhat upward forces is equal to somewhat downward forces, we heard that one. Okay na? And followed
Yes,
by
sir.
positive forces are there, negative forces, then this direction is reverse is there. clockwise momentum is will be there, anti-clockwise. These all are considered directions, not the values, negative values or positive values. Where thermal, where the temperature have positive and negative values. So that's why the green have thermal properties like a non-physical loads which can be caused by natural or unnatural, which we can specify natural or natural. Means natural means atmosphere temperature, unnatural means we are burning it.
Okay.
So these two types will be there, and followed by blue color will be there. Blue means study of fluids, study of fluids. Okay, so if any
Okay.
fluid is heated or any fluid is flowing from one point to another point, then the blue color should be used.
Okay.
Okay, we are not right now, we are not discussing this one. End of the section we can see this one. So right now we have to see mostly green and red colors only, because the maximum of analysis will be done in this one. Only few of the analysis can be done in the blue color. That means only there is flow of the air or for flow of the wind is there, then only we have to consider blue color, otherwise no need to consider blue color. But right now we are discussing all these three. In the sections we can discuss all these three, no problem. But right now we are not going to discuss two things.
Okay.
Okay, na? So below that one,
Yes, sir.
below this one, below analysis system, we have a component system will be there, which is considered as individual setups. Individual setup, it is a pre-setup,
Okay.
it is individual
Okay.
step. We have to add step by step ourselves. Okay, we have to add every
Okay, sir.
steps by ourselves. It takes certain different type, so depends, it takes certain time to which setup you have to specify. But it is also okay, we can use this one or we can use this one, both we can use. But 90%
Okay.
people, 90% people only this one. Only for CFD simulation we use this one, otherwise we can't. We no need to use of this one, because only for CFD or only for fluent or if for study of the air flow is there. Only on that cases we can use these things. But rest of the time we use only the structural analysis here.
Okay.
Okay, now
Yes, sir.
I'm going to click on the static structure here. Okay, I'm going to click on static structure, drag and leave it over this box. Okay,
Yes, sir.
so here we can see one name called as project schematic. You can see one name is called as project schematic, which is the identification or folder of the project. Folder of
Okay.
the projects. So how many projects you can do? So you can do infinite projects, but this is considered as a project schematics which having templates, which holds the templates. That's it only.
Okay.
Okay, na? So see this one, we got a template, right?
Yes, sir.
So in the template we can see certain names. I'm going to
Yeah.
call this template as tab A, because A is there. That's why I'm going to call as tab A. If multiple is
Okay.
there, tab A, tab B, tab C, I can consider that one.
Okay, sir.
Now below that one, we can see certain names, right? 1, 2, 3, 4 number is there and followed by names also there. This name
Yes, sir.
section is there, right? This is called as shells. This is called as shells. Shells means how many subsections are there.
Okay.
Now, in the first cell, we can see the name of the analysis, what we are doing it. Name of the
Okay.
analysis or type of analysis, what we are doing. We are doing static structural analysis. That's why it is a static structural analysis. Now, we can see static, right? Static is there and
Okay.
structure is there. Static and structure is there. Static can I call as rest,
Yes, sir.
rest, and structure means can I call as physically applied loads.
Yes, sir.
So that means a body is at rest position, the body is at rest position and physical loads are applied on it.
Okay.
The body is at rest position and we are applying a physical loads over it. That's why it is called static structural analysis.
Okay.
Same thing, one more is there. Suppose the body is moving here. The body is moving. One place to one place is moving. And still we are applying a load.
Okay.
Can I call as this is a moving, right? Can I call as it is moving, right? So that's why I'm going to
Yes,
call
sir.
this one as dynamic.
Okay.
Okay, it is moving one place to one place. That's why I'm going to call as dynamic structural analysis. Or we can say that it will be traveling. It is not going to travel from year to year, right? It's going to
Yes,
travel
sir.
step by step, like that, step by step. So whenever we are seeing the step, that will be called as transient.
Okay.
Here we can see transient structural analysis. We can discuss this one later, but so one more analysis will be there. Both are structural analysis only, but it is called as transient structural analysis.
Okay.
Body at rest position, body at motion. That's it. You have to remember only two things. Body
The
is rest position,
transparent,
body is motion.
transparent. Okay.
Hmm?
Transparent.
Transient.
Okay.
Transient అంటే movement of the body or moving bodies అని అర్థం.
Okay.
Or we can consider step by step move bodies or step by step arrangement of the body momentums.
Okay.
Okay. Now we can see this second one, right? This one,
Yes, sir.
engineering data. So engineering data means the properties of engineering materials.
Okay.
So when you click on this one, we can see different types of material. But actually what happened means from 2014 to 2018 software, 2014 to 2018, we need to select manually. We
Okay.
need to select them manually. But unfortunately, from the 2019 to 2023 version, okay, it doesn't require to select this engineering data.
Okay.
Okay, software itself have a inbuilt mechanism which allows to select the materials.
Okay.
Before we have to select our manually, we have to select manually. But unfortunately, due to the research and development process, it taking the time. That's why the software developers made sure that no need to worry about selecting the materials. We can select later also, is it?
Okay.
Okay. So that's why I'm
Yes, sir.
not doing this one because no need to worry about that one. But there is one analysis there called as composite material analysis. In that one, we can see that one. But right now, it doesn't require that one. Next, I'm going to select
Okay.
this the engine geometry. ఒక్క నిమిషం 1 minute.